Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 134 gas station. So before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking? That you are given stations, and on that station you will get some fuel, but in order to travel from ith station to I plus 1th station, there is certain cost involved. So you have to pay that cost in terms of your fuel to reach that station. So what it is asking is that you have to start from any station, but you should be able to do the whole circle. By whole circle means if you start from this, you go to this, and then again you go to this station, and again reach to the starting point. This is what you have to do. And also the car has a ultimate gas tank, so it can carry any amount of fuel. So this much is clear. Let's take example to solidify what I told. So this is gas array, and this is cost array to go from I station to I plus 1th station. So let's picturize this. This is 1, 2, 3, 4. This is the fuel that we get at this station, and this is the cost. Let me write it over here. 3, 4, 5, 1 and 2. 2 for this if we get this. So in order to travel from here to here, you required 3. From here to here required 4. From 3 to 4 you required 5, and from 4 to 5 you required 1, and from 5 to again 1 you require 2. So this is a graphical representation, not graphical, pictorial representation. So what we will do is, let's take this station. In this station what we get, and also in initial car has 0 fuel. So at this station we get 1 fuel, but we spend 3, so we cannot travel from this to this. Get 1 and have to spend 3, so we don't have that much fuel. So let's take this. In this we get 2, but we have to spend 3 to reach this, so this is also not possible. Now let's take this. So we get 3, but we require 5. We need to spend 5 to reach from I to I plus 1. This is also not working. Let's take this station. At this station we get, what just happened, it froze. Yeah, it's back again. So we spent, what we spent over here, 5, and this is not possible. We are at 4 over, we are at 4 over at 4. So what we get 4, and we spend 1, so we will be able to do that. So over here we will travel, and we have how much fuel? We have 3. This time we will get 5, In total we have 8, but we have to spend 2, so after that we have 6. So we have 6. Now we go to 1 again. Now when we are at 1 we get 1, so we have 7, and 7 minus 3, it's 4. We have 4 over here, we had 7 over here, 4, and we get 2. 6 minus 4, how much? We are left with 2, and 2 plus 5, not 5. At 3 we get 3, so we have 5, and 5 minus 5 is 0. But we reached where we started. Here we had 7, 4, then 2, then we got 3 from here. 3 plus 5, and we had 5, and also 5 is required, so at this position it is 0, but we reached the position, the initial and the starting is same, so we reached. So we will return, what we will return? The index. What is the index? If it is 0, 1, 2, 3, so we will return 3, as you can see over here. So this is the problem and how it is working. So now the question is how to solve this. So if you do this approach, pick one station and then see how long it goes. That approach is O(n) square. And also in this test case we are able to judge that we will not be able to travel to this in one computation, but in many cases that can happen, that you go to till this station and then you are not able to go further. So you have to check every station. That's why O(n) square, but n is 10 to the power 5. Let me check. N should be 10 to the power 5. Yeah, it is 10 to the power 5. It is 10 to the power 5. So we have to do something in O of n. O of n. So let's take this case only. This one is the station that we can start from. So let's again draw this. 1, 2, 3, 4, and 5. And how much is required? Required 3, 4, 5, 1, 2. 3, 4, 5, 1, 2. This much is required. This much is required. Let me check. 3, 4, 5. Yeah. So we are starting from this station. So let's see how much fuel we get. 1 plus 2, 6. 6 fuel we get, and how much is spent? This is 7 and 12. Get and 12 is spent. So how much fuel is still required? Minus 6. Minus 6 is spent. Minus 6 is spent. And what we have? And we have 0. Minus 6 is spent, and what we have? 0. Because in fuel gauge you can not have minus 6. So you need something to make this a 0. Because this is the journey. This journey requires -6 to complete, because we had 6, we required 12, so we have to fill this gap of 6. So how we get that gap is, because when we start over here we got 4 and we spent 1, so we have 3, and 5 plus 3 8, and we spent what, 2. So when we are at this point, how much fuel we have? 6. So if we have 6 and this journey requires 6, -6, we have +6 and this journey require -6, then we will have 0. Then this 0 means we reached the point where we started. So what we are doing over here is, what we will do, let me again make this. So what we will do, for this case we know that if we start from 4 we will be able to reach, but what we are doing over here is, if we get negative, that means that we cannot travel this station, we cannot travel this distance if we get negative. And if we are not get what we get, we collect the left fuel and check in the previous that if we have enough collected fuel to fill this previous. That's what we are doing. So what we will do is, the algo part is, we will have previous variable and current variable. In current, what we will do is that we will check if we can go from I to I plus 1. How we check? Simply by what we get minus what we spent, and if that is less than 0, so what we will do, what should be done, because this station is not good, so there will be a start variable. So what we do, we will just go one step, and also we have to reset this. So now current is 0, but in previous we will store this. Why we are storing? Because as here I discussed that we got 6, but we have to spend -12 to reach this, so there is a gap of -6. But if we get 6 initially in this condition, we were able to get that 6, that's why we were able to do it. What this -6 is saving is that O(n) square, because we don't have to loop in order to check, because in previous you have to use this much fuel no matter what. So this is a constant value. Only thing we have to do is check that we have this much fuel or not. So if it is done, we will just keep on iterating, and after that, when this we have taken all the station one by one, then what we will check, if this previous is less than 0, it means what it means in this situation, previous got 0, because we had -6 and we had +6 over here, so previous got 0. But if previous is still something negative, so what it means that we cannot do because we have already traversed every station. So what we will do is we just return -1, and if it is not less than 0, what we do, we just return the start, because we can start from that station and this is the start. We will always account the start. So let's see the code, how it is going. So this is the code. Yeah, basic size, this is surplus. I did write it surplus, or we can even write this as current copy current, what I copy current, start is same, current, and this is, we can name this as previous. I hope this run, because I'm changing every variable. Let's see if it is running. That's what happened when you change variables. Yeah, so what we are doing, the size, the current, the previous, and the start. Why we are taking start? In order to get which index or which station we should start. So we simultaneously calculate previous and current because both are same thing, both are calculated same. We can do this in one line also, but I did in 2 lines. And what we do, if the current is less than 0, it means we cannot do that I to I plus 1. We cannot do that I to I plus 1. So what we do, we reset that current and leave that station, move to next station. That's why we increase the start, and we keep on doing that. And after that, when we get out of this for loop, what we check, if it is less than 0, means we cannot find any station, and if it is not less than 0, we just return the start. So let's dry run this and see. Yeah, instead of, let's run, let's take the test case also, copy, paste. This is the test case. So 1 2 3 4 5 3 4 5 1 2. This is gas, this is cost. So let's do it. Here previous is what, 1 minus 3 minus 2, and current is minus 2. So what we do, reset to 0, and start is over 0. Now it is over 1. Now start is at 1. Again 2 minus 4 minus 2 minus 4, and again we get minus, again we get to 0, again we change it to 2. 0 1 2 3 4. So now we are at over here, start is 2, again 3 minus 5, again minus 2, this time it's minus 6, and current again minus 2, again this happened, we again reset it to 0, and plus 1. Now we are at 3, and at 3 what we do, 4 minus 1 3, this time it's 3. This will not be executed, but what we do over here, what we do, 4 minus 1, it's 3, and this we plus 3, and we get minus 3, and you can see start is still 3. Now we are at 5. At 5 minus 2. At 5 minus 2, we still get 3. So this is 6. And 5 minus 2, 3. We get 0. So we can see previous we got 0. So if previous is greater than 0, what we do? Return start. And what is the start? 3. I hope this much is clear. It may not looks like how I described it, but this is just to show it, and this is how it's working. Basically same thing, but different representation. I hope this was clear. Let's submit it and see if it is running for all test cases. Yeah, it is running. I hope this much is clear. And if I was able to convey my intuition, so consider subscribing to this channel and liking this video and sharing with others. So in the end, you have to do what you have to do. So keep grinding. You guys are awesome. See you in the next one. Bye bye.